Right. I thought this week I'd ask for some suggestions for things people wanted to see. Pasquale suggested they want to see how you install and set up and use PyTorch on Myriad. They asked for an input file, so they've given us a link. I've grabbed what's there. It's in this Vim. So we'll try and create a test script out of that once we've got it set up. But let's see what we need to do to install PyTorch. So we go to the PyTorch website. It says install. It's got a bunch of instructions here for so PyTorch is quite a complicated package. It depends on CUDA. It depends. There are different ways you can install it. You can start with Conda. You can start with pip. We will install it with pip because that's quite a nice way of setting things up. I need to pick a version of CUDA. One of the things that tripped me up when I was testing this is it actually doesn't. You don't need to have CUDA pre-installed. It will install a version, and if, like me, you've installed a different version, it will definitely go wrong when you try to run. So we want the stable version because presumably these don't actually work. We'll start with pip. We'll grab CUDA 11.7 because I know this works because I've done some tests with this for a different thing. And it gives you this command here. So this is the install command you want to run, right? So let's get ourselves logged into Myriad. And here I am. So what I'm going to do is I have a slightly different configuration in my profile from everyone else's. So what I'm going to do is I'm going to change my profile so that it looks like everyone else's, and then you'll know what to remove and so forth. So I'm going to do a module purge, module load, default. So if you have a normal Myriad account and you haven't made any changes to your setup, this is what it will look like when you do a module list. You'll note that we have some things in here like the Intel compilers. We probably want to remove those because in the instance where we were installing a Python package that did compiling, you can end up in a weird situation where the things you built depend on libraries that are not linked into the Python interpreter. So I'm going to remove those. API compilers. Okay, so we do a module list. See that those are gone. We need to pick a version of Python. I'm going to load Python 3.9.10. I'm going to do the bare version of it. There is a version which has a bunch of dependencies pre-installed, but let's try and keep this simple so we don't cause ourselves any problems. It helps if I put the load command in there. The module list -t. Do which Python 3. So this is the version we've installed, right, in 3.9.10. If we run Python 3, we should get that run. Yep. Right, what we're going to do is we're going to install PyTorch in a virtual env. And we're going to do that because a virtual env is a really nice thing. It's like a bubble of packages. And it will keep the things we install separate from things that are in our home directory by default or in the system install of Python. It just means we can kind of guarantee that which packages we have in the environment. So let's create a directory for this. We'll call it PyTorch. If we go to there, we will create a virtual environment. So you do that with the virtual env command. And we need to give that a name. So we'll call it PyTorch. Then press return. And then what that will do is that will do a bunch of stuff where it will create a directory structure in there. It will create a symlink, I think, or possibly a copy of the Python interpreter, and install some base packages. So if we now look in the PyTorch directory, you see there's a bin, there's a lib, there's a pyvenv.config. So the next thing we want to do is activate that virtual environment, and what that does is set up the current shell to use it. So we do source PyTorch bin activate. And we'll notice that it's added the name of the virtual environment in brackets to my prompt to remind us that we're in there. And we now have essentially our own Python environment, right? If we do which Python 3, you'll see that it's now the one that's in my Scratch folder in this directory that we're in, right? So the first thing we should do, because I like to do it, install. We want to upgrade pip because it's almost always the case that your pip install is out of date. And we'll let it download a new version of pip. There we go. So we have pip 22.3. And then we want to run that command that we had on the PyTorch website. So let's get that. And for sanity's sake, I should point out you should not just like blindly install things. You should not blindly run pip install commands, because there is no validation whatsoever that things are not malware on PyPy. But I think we can reasonably trust this one. So let's do that. Okay. And then we let pip do its thing. Now, because I downloaded this earlier, it's not going to re-download those, because pip does this thing where it keeps a cache of your downloads, so it's also a bit more speedy than it did what I did before. You see it installs Torch, it installs a bunch of dependencies, including NumPy and all the CUDA libraries you need. While it's doing that, I'll show you on the other terminal what I've done is I've requested an interactive job on one of the nodes that has an A100 card in it, and we can prove that. So you do that by doing QRSH minus LGPU minus ACLIO equals L and the other options that you normally put in a script. Obviously in a production run you'd put these options in a job script, but here I just wanted to have something immediate so I could show off what we're doing, right? So if you do NVIDIA, we should be able to see that I have a single A100 PCI Express 40 gigabyte. So that's good. If we go back to this terminal, we can see that we've installed everything in the Python in the virtual environment. So over here on the GPU node, we want to replicate that environment. So let's do module per. So actually, if we do a module list, you'll see that I have some other modules in my environment, mostly things I like. So I quite like. There's this thing called the spreadsheet calculator, which is a command line spreadsheet and a bunch of other stuff. So that's the best way to do it. Let's do a module purge, module load default modules, and module move, what was it called? MPI compilers, and module load Python 3.9.10. Brilliant. Okay, so we want to go to the directory where the virtual environment was and activate it. So scratch PyTorch, source bin, PyTorch bin activate. Excellent. Right. What do we need to do now? We need to prove that any of this works, right? If we look back at that Vim, this script, the things in that script are slightly odd in that it does some things in duplicate. So let's create a little script like we would do if we were going to submit this as a job. Okay, so let's do Vim PyTorch. Let's call it test. Just call it test. Right. Let's have a look at the stuff in the script. Right, so some of this is duplicated, so let's get rid of these. So here it's going to print the device. I don't like doing device name 0. Let's have a quick look. I deleted too much. No, that's fine, I guess. Let's also print this out. And let's just put some text in here. Device name. Okay. Is there anything else we need? Right, I believe that should be fine. Let's see if we can run that with Python, right? Python 3. Well, obviously that's not fine because I've screwed up my close brackets. Too many, I think. Yep, and it's probably because it's falling on the floor. This import takes a while, and if you've done something foolish like I did the first time, where you've put your own CUDA into the environment, it's where it hangs and crashes. So there we go, it's run. It's picked the right device, it's that A140GB that we wanted. It's detected we have one. It's not using any memory at the moment. There's a deprecation warning here. It looks like something's going to change in the way CUDA works. Haha. So we could probably change that. So CUDA memory cache to CUDA memory reserved. Let's do that just to be nice. See how that works. Okay, right. Now, supposing you wanted to submit this as a job script, right? Let's try and do that. Right. So this should be old Pat by now. It's a shebang, right? We want to set a name. We want to request that it runs on the L class nodes if you want to use an A100. So ASCII allow equals L. And we do actually want a GPU, otherwise it won't let us run on those nodes. And then there's the normal requirements, so we should give it some memory. And give it some tempfs. And give it a runtime. So the mandatory for the flag, isn't it? Finally, you want to say where it's running. So where are we? We are okay. So what do we want to do then? We want to do the modules environment. So if we do module purge module load default modules module remove compilers API module load Python 3.9.10. We then want to bring in the virtual environment, so we do source PyTorch bin activate, and then we just to be on the good side, let's do an NVIDIA SMI and do and then run the script. Right, and let's submit that. Oops, I've submitted the Python script. You can actually do that. It's possible because Python has the same format comments as a shell script. You can build a script that runs through the Python interpreter directly. Maybe that's something I'll show off at some point. That's a silly thing you can do, but let's not do that right now. And it's submitted. Let's see if we get it to run. Right, I believe that's now run. Let's prove that to ourselves. Qstat. Yep, there's nothing left in the queue. If we do an ls, we've got some output files and the error files as we normally expect. Let's see what's in that. There we go, it ran successfully. So I believe, unless I'm very much mistaken, we've successfully installed and proved that PyTorch is working. Right, I'm back. It's the next day, and obviously I finished yesterday thinking I finished the video, but then I was sitting on the train on the way home and feeling generally grumpy that the example I'd done was basically a is there even a graphics card in the node kind of question. So I took a look at the PyTorch website to see if there was an example we could run, and they've got this quick start example here, which is the kind of standard default tests people seem to do with these frameworks. It used to be that they would do a very simple training set that involved handwriting and then proving that it could read like a letter. And eventually someone decided that that problem was too simple. And so now they use this data set, which is public, which is of quote-unquote fashion. The quick start page is very bad at describing what this is, probably because it's quick start and you're supposed to know what's going on here. But if we actually look further down the tutorial to the more in-depth version, if we scroll through this, it will show us some of the data set. Here we go. So this is what the data looks like, right? It's these really low resolution pictures of things, and they're tagged with what they are. I think you should pay attention to the ankle boot because that'll become important in a bit. So, we want to run the tutorial code, right? One of the really nice things, so what does the tutorial code do? So it pulls down the data set. So one of the nice things a lot of these frameworks have is a routine to pull some of these standard data sets without you really having to know about it. It does some training on it, creates a model, and then it saves the model, loads it back in, and then uses it to do inference. And the inference it does produces the answer ankle boot, which is unhelpful because some of the code here is like, what is X, what is Y, right? So I spent some time staring at this and again being very dissatisfied. This works, by the way. I happily ran it on a GPU overnight, and it does the right thing. So what I thought would be more persuasive would be if we could actually see the image it's doing. And this is where we get a bit down a rabbit hole of terrible ideas. I thought back to the past, and I might put a screenshot in here when I did this, when I've had to deal with systems which don't have any graphical output at all, right? A typical one is I have an emulated IBM System 370 running MVS2. It's on a Raspberry Pi in my flat, so I can play with machines that aren't terrible. And when you do things like draw a Mandelbrot set with that, there is no concept of drawing, right? You're printing out to a line printer. And so what we do there is we use this thing that we used to have in the past called ASCII art, right? And the simplest way of doing that is creating an array of colors, which are characters that represent colors, and printing them out to the screen. And so I had a bit of an aha moment last night, which is I can do this in Python and I can show this boot. So I went ahead and I wrote this. It's a very simple routine. You give it a 2D array of data. It so happens that the representation of inside PyTorch is what they call a tensor, and the item for an image is a two-dimensional tensor, aka effectively an array. It loops over it, works out where it should be along the scale of this structure of colors, whichever one you pick. So I've done 3. I've done like very basic Unicode grayscale. This string is from a Stack Overflow answer, like what is an approximate light to dark or dark to light of all the ASCII characters. And then for fun, I also stuck in some Unicode colors, which give you a really fun false color image. So what it does, you give it the data, you tell it what string, and you can supply your own string, right, if you've got your own thing. What string to use to pick the colors from. It loops over it, picks a color based on each of these values, and then prints it out to the screen. So this means you get terminal output that looks kind of like an image. So let's run this script, but at the end, when it prints out the prediction, also have it print out the image, right? And we'll use, I guess, all 3 of those so we can see what they look like. So if I bring back my terminal, right. So what do we need to do? You can see I've been mucking about in here because there are some scripts in here. So let us get rid of some of that, I guess. What's the best way to do this? Let's create a new folder called test or exercise. Let's try exercise. One of the nice things about the way they've done this stuff in the tutorial is if you come over here, there's a GitHub version which you can pull the raw script out of. If you click on raw, you get literally a Python script you can just run. And actually this problem is simple enough that you can run it in about 10 minutes on the CPU. So let's get that script. Okay. We also want to get that little routine I had. We could pull it into the directory, but I've actually, because I've stuck it in GitHub and it's currently in my repository of what I call garbage, which is where miscellaneous junk goes in. Let's have a look. We could just do a symlink. So if we do ln-s home source garbage snippets term show. Okay, let's do a symlink. So I've got all of those in there. So let's have a look at the tutorial code. So this is just doing the full kind of list of things. If we do, so at the bottom where it does the prediction, right, what we want to do is have it print out the images as well. So let's do that. Here's copy and paste some code I prepared earlier. So what does this do, right? It imports that library. It imports the show command and then the 3 sets of colors. I'll modify this slightly. So this says oops. Oh, now I've done a Vim. And fine, let's do emoji. The emoji gives a really nice, like, false color image because, of course, it's not like a good set of colors. I tried to order them roughly in terms of like brightness, but anyway, we should get all 3, and then we'll get the prediction of. So what this is doing is just printing out the one that like the test data that it's going to try and match. And let's see what happens, right? Right, so that's the script. We of course need to do a job script. I'm going to cheat a little bit and do one I prepared earlier. So if we, what do I call this? Quick start. So the difference between the original one and the version 2 is version 2 is not picky about which GPU it uses because we don't care, and this is a very small problem, and what we actually care about is getting through the queue quickly. Let's do that. Let's edit that in Vim. Make sure it's all got right paths and things. What do we call this? What's the exercise? Right, we should make sure this runs in the exercise folder. We don't need to do the copying, so I was trying to do something somewhat clever. We won't bother with that. we will just change these a bit so that it matches what we're actually doing. So we call the script that. Delete. And just run Python quick start tutorial show .py. Right, let's sanity check this. So shebang, name, request 1 GPU, any GPU, 4 gigs of RAM, a gig of tempfs, 30 minutes should be plenty. So run in this directory, set up the modules as before, activate the virtual environment, run NVIDIA ASCII to print out what the thing is, and then run the quick start tutorial.py. So let's make sure we've got those in the right place. Let's submit that. Oops. Well, that's annoying. I clearly screwed that up. If you look at the scripts, you'll see that I have managed to put the start directory inside the directory I want to work in, which would normally be great, except we want to pull in the virtual environment, which is one step up. So the script ran and failed because it didn't load the Python virtual environment. So I edited it and resubmitted it, and let's see what we get as output. Right, so the job has run. Let's log into Myriad and have a look at what the output looks like. So our stuff was in Scratch, PyTorch, and the job we ran was 45410. So let's have a look at the output. I'm going to pull this in through cat. So I've done this as a separate terminal because it turns out that less really does not like the emoji. So I thought I'd create a new terminal so I'd have a scroll bar and stuff so that I could show off the different things. So, well, the first thing we can see is that clearly looks like a false color image of a shoe, and probably even an ankle boot, right? And if we go back to this image here, it looks probably can reach stuff quite well. That is, in fact, looks a lot like that. Let's have a look at what we actually got as output, though. So, NVIDIA ASCII ran. This job happened to run on a V100, which is a generation older than the A100, so that's fine. Definitely seems like our installation of PyTorch works on that. You can see that the script does its thing where it downloads the various data sets, does its work, does its training, and then it does the test, right? So it saves the model, and then I got it to print out the image it's looking for. So here's our 3 character sets, right? So here is the one that's the like 5 level of grays that you can get out of Unicode. Again, that looks pretty much like the boot. This is the one that uses ASCII. That's probably the least convincing of them, I think. And of course, here's the one that uses the brightly colored emojis, right? And we can fairly clearly see that's the ankle boot. So it looks like the code has worked. So there you go. It's fairly easy to install PyTorch. It's fairly easy to get it to do things. So you have to be very careful when you're juggling about Python virtual environments that you load them correctly in your scripts. Other than that, everything is great.